displacement. Instantaneous acceleration is equal to dv by dt, and as we have already seen that v is equal to ds by dt, so a will be equal to d by dt of ds by dt, which is d square s by dt square. So this is one more formula for instantaneous acceleration. Also we can write dv by dt as dv by ds into ds by dt, and we know that ds by dt is nothing but v. So acceleration can also be defined as v into dv by ds. Now average acceleration was v final minus v initial by t, where v final is the final velocity, v initial is the initial velocity, and t is the time interval. Now let's find out the various equations of motion. A complete description of the motion of particle can be obtained if the mathematical dependence of its position x at any given time t is known. That is, if we know the relationship x is equal to ft, then we can very well describe the complete motion of particle. So now let's find out the relationship between velocity and acceleration when acceleration is constant. We are assuming that we know the relationship x is equal to ft. So since we already know how x is dependent on time, that is, we know the relationship x is equal to ft. So from here we can define velocity, which is v, as dx by dt should be equal to f dash t. So now the time dependence of velocity is also known, and it is equal to f dash t. Now we know that acceleration is nothing but dv by dt, or we can write dv is equal to a dt. Now since the acceleration is constant, that is, it is not dependent on time, we can integrate the left hand side and right hand side of this equation. Now suppose at time t is equal to 0, the velocity of the particle is u, and at time t is equal to t, or at any given time, the velocity of particle is v. So after integrating, we get v minus u is equal to a into t minus 0, or at. So v is equal to u plus at. So this means that velocity at any given time v will be equal to initial velocity plus at. Now let's find out the relationship between the position of particle, its